Okay, let me put this on record. And the stuff we're going to go over tonight, are you going to verbalize it?
Yeah.
Okay, what do we got tonight?
I have 18 problems here.
Okay.
It's just on factoring again.
Okay. It's probably a good idea to verbalize these. I think the student learns something when you verbalize factoring problems.
Yeah.
Okay. Go ahead.
Alright, so the first one is x squared.
Yeah, sorry. I always forget I got to do this. Okay. Oh. And hold on a second. What happened to my drawing tablet? Hold on, let me unplug it, plug it back in. These computers can be a little touchy every now and then. Hold on. Hold it. I saw something. There we go. All right, go ahead.
Alright, x squared plus 14x plus 45.
I want you to do this in 3 steps. Tell me what the first step is.
Alright, so x is on both sides.
Step 2.
And then plus on both sides.
And step 3. Verbalize step 3.
You factor 2 numbers for 45 that add up to 14.
What are those numbers?
9 and 5.
Does it matter which one I put where?
No.
Okay. Because they're both plus. If one would have been plus and one would have been minus, then it's going to matter. Then we have to have a 4th step. Okay, go ahead. Next one.
Alright, it would be... hold up. Alright, so now there's 2... Okay, yeah, so w squared minus wd minus 56d squared.
Okay. This is a little different. What's the first step?
So you'd put w on both sides.
Okay. As long as those 2 w's multiply to that term, we've done it correctly. Okay. Second step.
You would look at, and so the subtraction sign, it would be, wouldn't both of them be minus?
Oh, if they were both minus, this would be a plus.
No. 1 minus 1 plus.
Exactly. It's plus minus. Now, because I have w and w, it does not matter whether I put plus minus or minus plus. If I had 2w times 3w, then it would matter, and I would have to allow for both situations. Okay? Now, we're looking for something that's a little unusual. It's a little bit of an unusual factoring problem. We're still looking for factors of 56d. In other words, this last thing here is not just going to be a number, it's going to be a number with a d.
Okay.
So let's look at 56. Factor that for me. Give me all the factors of that. What's the first factor? That's the first factor. What's the next factor?
So it would be 56 and 1, and then it would be 2 and 28.
Keep going.
And then it would be 3 doesn't go into it. And then
always try to cut this in half. The thing on the left.
Okay, so then it would be 14 and 4.
Keep going.
And then it would be 7 and 6.
7 and 8. If I'm going
8.
to cut 14 in half, I got to double 4.
Yeah.
Now, if I try to go any further, 7 is prime. So I'm not going to divide anything into 7. So how about 8? Well, I could cut that in half and double that, but that doesn't really give me a new set of factors. That gives me the same set. Okay? So once I get to this point, I'm pretty sure I've found all the factors. Now, let's pretend we don't have this WD or D squared. What would the rule be?
It would be
Factor what?
It would be factor 56
That
or negative 56.
no, don't worry about those signs yet. It's factors of 56 that do what? That tells you what they have to do.
Subtract to 1.
Exactly. Which factors do that?
56 or
Well, just look at all the factors that I've come up with.
7 and 8.
7 and 8. Okay? Now, the 8 goes with which sign?
The 8 would go with the positive.
No, it always goes with the sign of the middle term. Middle term is minus 1. So that 8 needs to go on that side, leaving the 7 over here. Now, notice that that would give me, if I were to multiply just that, I would get W squared minus W minus 56. That would be my quadratic. Well, they've added a second variable here. So what if I just add that second variable right there like that? Now notice what we get when we multiply them together. We still get the W squared. In the middle, we get plus 7 dy. On the outside, we get minus 8. I didn't mean dy, I meant dw. On the outside, we get minus 8 dw. So here, let's do the inside. That's 7 dw. The outside is minus 8 dw. Add those two together, you get minus 1 dw or wd, however you want to write it. So this set of factors that I've come up with produces that term, it produces that term, and what's it produce on the end? Minus 56d squared. So for sure this is a little bit harder because they've added a second variable, but we use exactly the same method for factoring as we would to factor this. If I took away the d and I was factoring this, I'm going to use exactly the same method as I used to factor with the d. It takes a little bit to get used to that. That was pretty advanced, actually. I'm surprised they gave you that one. What else you got?
X squared minus 4x minus 12.
Do this one quickly, all 3 steps. All 4 steps. This always means there's going to be a 4th step.
Alright, so it would be x on both sides, and then it would be a plus and a minus, and then factors of 12 that subtract to be 4 would be 6 and 2, and the 6 would be on the negative, and then the 2 would be on the positive.
Beautiful. That's how fast I would expect you to do it. Once you're expert, you did that very, very nicely. What else you got? Give me stuff you don't know. I don't want to waste our whole half hour doing stuff that you already know how to do.
I mean, here, let me look through some of these.
Yeah, see if you can find one that just gives you a little bit of puzzle. like the previous one that had the WD.
Oh, here's one. Okay.
Okay.
X squared
Uh-huh.
plus 15xy minus 76y squared.
Notice they've done the same thing with this as they did with the other one. They've added a y, but it's not going to change the way we do it. First step.
X's on both sides.
Next step.
And then it would be a plus and a minus.
Absolutely. There's
Yeah,
only
and
one way
then
you can produce that minus, and that is if you
right.
have opposite signs.
And then
Okay.
factors of 76.
Factor that.
Would be 15. So it'd be 1 and 76. And then it would be
A good skill to have in math is cutting numbers in half.
it would be 2 and 38.
Okay.
And then it would be 4 and no, 4 doesn't go into it.
You're not looking to divide it by 4. Let's look at this a little different way. What you're doing is looking to cut 38 in half. Can you cut 38 in half?
Yes.
What is it?
19.
Which means you have to double the 2. If I was able to cut 38 in half, then I got to double the other side of it. 4 times 19 has to be the same as 2 times 38.
Okay, that makes sense.
Now, 19 is prime. I cannot divide it by 2. I cannot divide it by 3. I cannot divide it by 5. I cannot divide it by 7. So it feels like I'm done with this. I could cut 4 in half to get 2, but that doesn't help because then I just get 2 and 38 again. What am I looking for? What set of factors? What do they have to do?
It has to multiply to be 76 and then add to be 19. Or, subtract to be 19.
Not to be 19.
Or 15, sorry.
Okay. So, I'm just going to do the whole problem as if that y is not there.
Okay.
So, where's the 19 go?
The 19 would go the plus, and then the 4 would go minus.
Now, I'm almost done, but not quite. They do have a y and a y squared up there. So what do I need to do with that y?
Just add it onto the 19 and 4.
It goes with the 19 and the 4. Now, you're still going to produce the x squared. You're definitely going to produce this minus 76y squared. Let's see if we get the correct middle term. It's always worth checking the middle term. Well, that's plus 19xy. And this is minus 4xy. Add those two together, you get plus 15xy. Which is our middle term, which means we've done it correctly. So these problems with two variables, you can use the exact same method as I use with first level quadratics. It's not even as hard as a second level quadratic. If we have any second level quadratics, let's give one of those a shot also.
Okay.
By second level quadratic, I mean anything that has a coefficient in front of the x squared term that's not 1.
Okay.
These are a little more difficult to do.
Okay.
But you're pretty good with the other ones. So I'm satisfied that you really know how to factor single level quadratics. Maybe they haven't given you any second level ones yet.
Yeah, no, they haven't.
I haven't? Okay. Well, pick the next hardest one. So everything that you have on your sheet is pretty much like the ones we've done?
Yeah.
Pick the hardest one.
All right, let me look. Oh, they give me a word problem.
Okay, let's have that one.
All right, it says the area of a rectangular rug is given by the trinomial r squared minus 6r minus 55. What are the possible dimensions of the rug?
Okay. So there's our rug. Now, what's the definition of area? Have you had geometry yet?
No.
Area is base times height of a rectangle. So, I'm going to multiply the base distance by the height distance to get the area. Which means what I have to do is factor that. Once I factor it, that's going to give me two things multiplied together. One can be the base, the other would be the height. So let's factor that. Step one.
All right, r on both sides. And then it would be both subtraction signs.
No. Always look to that as your second step. That tells you what both signs are going to be.
Yeah, both subtraction.
Nope. If they were both subtraction, it would have a plus sign there. Minus times a minus is a plus.
Oh, yeah. Okay.
So they got to be opposite. One's got to be plus, one's got to be minus.
Okay.
Okay, that's always the second step, is to check that sign in front of the constant. That will tell you what both signs need to be.
Okay.
Now, what's the third step? Factors of 55 that do what?
Subtract the 6.
Well, that's 11 and 5. Where's the 11 go?
The 11 goes on the negative?
Goes with the sign of the middle term, the bigger factor.
Okay.
Always goes with the sign of the middle term.
Okay.
Which will
and then
be 5 there.
Yeah.
And now my dimensions are pretty easy. R plus 5 is the base. R minus 11 is the height. Or vice versa. Now, to get the area of that rug, I'm going to multiply the base times the height. So I'm going to multiply R plus 5 times R minus 11. And I already know that's what I get, right?
Mm-hmm.
Because factoring is just the reverse of foiling. So I've got the right area. I've got two factors. The only other answer, what's the only other answer? Besides that one.
I don't know.
How about I switch them? How about I make this one R minus 11, and I make this one R plus 5. Now the area is still this times this. Doesn't matter what order I multiply them together. So this could be an answer also. The base might be R minus 11 and the height might be R plus 5 instead of the other way around.
So,
Go ahead, ask.
all right, so it's asking like what the length and the width of the rectangle would be.
Okay. Well, there's a lot of answers. Did they give you an area? Did they give you a number? Okay. So, let's say R's got to be at least 12, right?
Mm-hmm.
If R was less than 12, we would have a 0 dimension. We wouldn't have a rug. Pi, come on in. Pi, come on. So, R's got to be at least 12. Well, let's make R 12. Let's let R equal to 12. Okay?
Okay.
That makes the height of the rug 17 the length of the rug 1, the area would be 17. If I plug r equal 12 into this quadratic, I'm going to get 17. Well, what else could r be? R could be 13. And if r is 13, this is going to be 18 times 2. It's going to be a bigger rug. So this quadratic that they give you for the area does not tell you how big that rug is. It just tells you that it's the product of r plus 5 times r minus 11. So the only thing it really tells you is that r has to be greater than 11. Otherwise, we wouldn't have a rug. In other words, you can't have negative dimensions. If r were 10, this would be a minus 1 width. You can't have that. You can't have r equal to 11. Then we would have a 0 width and we'd have a straight line. We wouldn't have a rug. So r has to be greater than 11. But it can be anything. It can be 11, it can be 15, it could be a million. And everything would still be true. The area would still be r squared minus 6r minus 55. And that would be the base and that would be the height, or vice versa. Okay? You're taking Algebra 1?
Yeah.
I'm actually surprised they gave you that problem because that involves some geometry. And you haven't had geometry yet. So what else you got?
All right, let me look through here.
I can make up a level 2 one if you want. Just it seems to me like you know this stuff pretty good. When I find a student that knows the current material really well, I like to go a little bit forward. Because if we go a little bit forward, you'll be much more prepared when you go to class and they start giving you these harder ones.
Yeah, sure, let's do it.
All right. It's hard for me to make one up without setting it up to begin with. So, in other words, I'm going to multiply those two together. I'm going to get 2x squared. I got plus 3x minus 4x. So that's minus x minus 6x. Or, sorry, I didn't want that there. Okay. So, now I'm going to go backwards. I'm going to erase that. In other words, what I now know is that I have a quadratic that can be factored.
Shouldn't just be 6 instead of... Yeah, okay.
Thank you. So, let's factor that.
All right.
A little different than the other kind of factoring. And you'll see why. First step is the same. Split up the 2x squared. What does it got to be?
It'd be it'd be x on both sides.
Well, now hold on. If I do that, is that going to give me 2x squared as my first term?
Wouldn't it be 2x?
This term, it's worth knowing that that term comes only from that times that. Nothing else. So whatever I put down here has to multiply to 2x squared. So what do I got to put down there?
A 2?
One of them's got to have a 2 in it.
And then the other one is just x, right?
Exactly. So I've got 2x times x. So in this case, when I split up the 2x squared, I don't get the same coefficient in front. One of them has a 2, one of them has a 1. Second step, same. What's the second step?
It would be a plus and a minus.
Okay, but because these coefficients are not the same, plus minus is not the same as minus plus. So I have to allow for both.
Oh.
And this is where it gets more difficult. And the third step, you don't have any simple rule like factors of 6 that subtract the 1. Those rules no longer apply once you get to second level quadratics. What you have to do is trial and error. There are only two sets of factors for 6. That's 6 and 1 and 3 and 2. Now, what I tell everybody to do, and this is the way it usually works in Colorado, is it's a trial and error process. We don't want to go through more calculations than we need to. So always start with the two closest factors, 3 and 2. Okay? And it's just totally arbitrary. I'm going to put a 3 there and a 2 there. I could have done it reverse. I could have put a 2 on the left and a 3 on the right. I don't have any idea at this point which is going to produce the correct answer. This answer I have, 2x plus 3 times x minus 2, what does that produce as a middle term? That's always the key. Is the
that produces
I of FOIL. I know it's going to produce 2x squared, and I know it's going to produce minus 6, but does it give me this middle term of minus x? That's the question.
it does.
It does. Exactly. Right? The inside is plus 3x. The outside is minus 4x. Add them together, you get minus x. So, my first try, I was lucky. I got it right away. Okay? Well, let's pretend that I wasn't so lucky. And I put, instead of starting where I started, let's try to the 3 here and the 2 there. You see where that's different. That's not the same. It's not going to give you the same answer. What does this give you?
That would give you minus 3x and then 4x, so that would be a positive x.
It's the right number, but the wrong sign. Give you a plus 1x. Whenever you try a set of factors and you get the right number but the wrong sign, so all you have to do is move it to the other sign. Take the 3 away from there, put it up there. Take the 2 away from there, put it up there. That's going to give you the same number but the opposite sign. Okay? Now, before we leave this problem, let me point out a couple of other things. Let's say I put the 2 over here and the 3 over there. Remember, there's 4 possible combinations just using that set of factors. I can go 3 and 2, 3 and 2, 2 and 3, 2 and 3. So there's 4 different combinations. When I say trial and error, a lot of times you got to try all 4 of them. But some of these tips I'm giving you are helpful because you actually are trying 2 sets at the same time. You'll notice, what do these give you as a middle term?
That would give you positive 2x, and then it would give you negative 6x, which is negative 4x.
Wrong sign, wrong number. Well, correct sign, but wrong number. The number is what you want to get. Okay? So, that not only eliminates this answer, but I know that if I move the 2 down to the negative sign and the 3 down to the positive sign, is all it's going to do is make that a 4x instead of a negative 4x. So I know that I cannot have the 2 on the left side. So even though I've only tried one trial, I've eliminated 2 possibilities. Right? In other words, there's no way I can have that 2 on the left. I've got to have the 2 on the right and the 3 on the left. So the next thing I'm going to try is the 3 over there, the 2 over there. That happens to give me the right answer, and I'm done. If it doesn't give me the right answer, I move it down 1. That should give me the right answer. If I have tried all 4 possible combinations with 3 and 2, what's my next step?
You move to the next closest factors.
I try 6 and 1.
Mm-hmm.
And that is the nature, and that's why I call these the harder ones, is because there's a lot more work involved in factoring. Most of the problems you're going to get in the state of Colorado, the answer is going to lie with these 2 closest factors. Okay? But you can imagine some really difficult problems. How about something like this? Now, break up the x's.
All right, so it would be 2x and 2x, and then it would be 2x on the other side as well.
Well, that's one possibility, but can't it also be 4x and x?
Yes.
So all of a sudden we have 2 choices for the first splitting up the x's. And now let's look at the factors of 24. We got 24 and 1, cut that in half, 12 and 2, cut it in half again, 6 and 4, cut it in half again, double that. Those are all my factors of 24. So when I get to this step here, I'm going to tell you try 6 and 4 because they're the 2 closest together, but there's no guarantee that that'll be the answer. And you can all automatically see that I got 2 different choices for splitting that up. I got 4 different choices for splitting that up. That means there's going to be 8 possible answers. And I have to keep searching through various factors and combinations until I produce that minus 10x. Now, I made this one up off the top of my head, so I don't even know that it factors. Okay? And there's a lot of things that don't factor. Here, let me give you one that doesn't factor. Try to factor that.
Okay, so 1 and 9.
Start with step 1.
Oh, you want me to do? Oh, fine. Okay, so x and then x on the other side.
Both sides?
And then the signs, it would be a plus and a minus.
How do you get a plus if you start with a plus and a minus?
Oh, both minuses.
Correct. The first answer is they both have to be the same. They either have to be minus minus or plus plus.
Okay.
Then you look to that term. Since that's a minus, that tells you they have to be minus minus.
Okay.
Now what's the third rule? Factors of 9 that do what?
That add to be 7.
There aren't any. There's one factor of 9. There's the only other one. None of them add to 7. What that means is we can't factor that in the normal way. There is a way to factor it, but you got to use the quadratic formula. And I don't think they've taught you that yet. So just the only reason I'm pointing this out is that you can have quadratics that might not factor easily. This is called factoring it easily. This is the quadratic formula. And you can see there's nothing easy about this. You will learn it. They'll make you memorize it. And they'll show you how to use it. But that's a lot harder than factoring. So just know that some quadratics can be factored, some can't be. And if you can't factor them, you always go to the quadratic. And at some point, I'll show you how to do that. But just so you know that all quadratics cannot necessarily be factored this easy way. All right, Blake, I'm going to let you go. You have a good rest of your evening. We have some more appointments scheduled, and keep bringing me that new material. They'll go pretty fast now. I suspect the next time we talk, you'll have some second level quadratics, or they will have taught you the quadratic formula or something.
Mm-hmm.
But they'll do something more progressed than what we've worked with tonight.
Okay, thank you very much.
All right, and next time, remember, I'm only going to text you the meeting ID number about 2 minutes before our session time. So
Okay.
you don't need to call me. I'll automatically text it to you. If I'm 5 minutes late, then feel free to call me, but I try not to be. I try to be on time every session. And I usually try to get the meeting ID number texted before the session starts.
Okay.
Okay?
Thank you.
Mike, have a good one. Talk to you later.
You too.
Bye-bye.